Hey there. Ever just look around at the chair you're on, the air you're breathing, maybe even the stars up in the sky? What do they all have in common? Well, they're all made of stuff. But what is that stuff, really? We're going to break it down.
But first, let's start with the classic question. Think about it. Ice, water, and steam. They're all the same thing, right? Just H2O. So how on earth can one single substance be a solid rock, a flowing liquid, and an invisible gas? It feels like magic, but it's pure science, and we're about to uncover the secret.
All right, so to solve that whole ice and water mystery, we've got to get on the same page. We need a word for all this, well, stuff that makes up everything. The good news? Science keeps it super simple. The word is matter.
And the definition is actually pretty straightforward. Basically, if something takes up space, has volume, and it has mass or weight, it's matter. So your phone, that's matter. The coffee in your cup, that's matter. And here's the kicker. Even the air, which you can't even see, yep, that's matter too. It's taking up space in the room right now, and believe me, it has mass.
Okay, so we know what matter is, but it obviously doesn't just come in one flavor. We run into it every single day in three main forms, or states. Let's dive into those.
So first up, we have solids. Now, picture this. Inside a solid, all the little particles are crammed together, like people in a sold-out concert right up at the stage. They're all buzzing with energy, kind of vibrating in place, but they are absolutely locked in. They can't go anywhere. And that's why a solid, like a rock or a table, holds its own shape and its own volume.
Okay, next are liquids. So if solids are that packed crowd, liquids are more like a dance floor. The particles have a bit more room, a bit more energy. They can slide and glide past each other, moving around freely. That's why a liquid will take the shape of whatever container you pour it into. It can flow, but it still has a fixed volume. You pour 8 ounces of water into a tall glass or a wide bowl, it's still 8 ounces.
And that brings us to gases. For this, forget the concert. I want you to imagine a room filled with thousands of super bouncy balls, just ricocheting off the walls, the ceiling, the floor, everywhere. That's what gas particles are like. They have a ton of energy, and they just fly around like crazy, spreading out to fill literally any space they're in. That's why a gas has no definite shape or volume.
So let's put it all together. You've got solids, rigid, can't really be squished. You've got liquids, they flow, but they're also pretty hard to compress. And then you have gases. They're all over the place, and you can definitely compress them. 3 very different sets of rules for 3 states of matter.
Okay, so that's the what. We know the difference between a solid, a liquid, and a gas. But we still don't have the why. Why do they act so differently? Well, to figure that out, we need to shrink ourselves down, way, way down, and enter the secret world of particles.
And here it is, the big secret. It's all about motion. The whole thing, solid, liquid, or gas, is decided by a non-stop dance happening on a microscopic level. It's all about how these tiny, invisible particles are moving.
You know, this idea is so important, so fundamental to chemistry and physics that it has its own name. It's called the kinetic theory of matter. And it's basically the rule book that explains everything we're talking about. The core idea? Everything is made of tiny particles. And, this is the key, those particles are always moving.
All right, so this particle dance is basically a tug of war between a few key things. First, you've got kinetic energy. Think of this as the energy of motion. When you add heat, you're just cranking up the kinetic energy, making the particles go wild. Then, pulling in the other direction, you've got intermolecular force. This is like the glue, the attraction that tries to hold all the particles together. And finally, there's the intermolecular space, which is, just the gaps between the particles. And when you see them side by side, it all clicks. In a solid, that glue, the intermolecular force is super strong, and the particles don't have much kinetic energy, so they're stuck together. But in a gas, the kinetic energy is off the charts. It completely overpowers the forces, so the particles just fly free. And liquids? Well, you guessed it. They're the happy medium, right in the middle, with a balance of both.
Okay, so once you get this tug of war between energy pushing particles apart and forces pulling them together, you suddenly understand how matter changes states. Like how ice melts into water.
It's actually really elegant when you think about it. If you want to change the state of something, all you have to do is tip that balance. You add energy, say heat, and the particles start moving so fast they break free from that intermolecular glue. And if you want to go the other way, just remove the energy. Cool it down. The attractive forces take over again and pull the particles back into line. And this simple rule explains even the weird stuff, like sublimation. Ever seen dry ice? It doesn't melt into a puddle. It just vanishes into smoke. That's because you're giving the solid particles so much energy so quickly that they completely skip the liquid phase and launch straight into being a gas. Super cool.
So we've seen that matter can change its shape, its form, its state. It's pretty flexible. But through all of that change, there is one single, unbreakable law that governs everything. Let's zoom out and look at the big picture.
It's called the law of conservation of mass, and it's a mouthful, but the idea is simple. You can't create matter out of nothing, and you can't destroy it. All you can do is change its form, rearrange the pieces.
So, how do we know this for sure? Well, scientists came up with a really clever and classic experiment to prove it. Here's the setup. You take two clear liquids, you put them inside a sealed flask, and then you place the whole thing on a very, very precise scale.
First thing you do is get a starting measurement. You weigh everything together. Let's say, for example, it weighs exactly 261.947 grams. We're talking super precise. Every single atom has been counted.
Okay, now for the action. You tip the flask, the two clear liquids mix, and boom, a chemical reaction kicks off. All of a sudden, a new white solid material appears out of nowhere. It's called a precipitate. You can clearly see that something brand new has been formed.
But what does the scale say? And this is the part that is just so cool. The number on the scale hasn't changed, not even a tiny bit. It's still 261.947 grams. Even though it looks totally different inside the flask, the total amount of stuff is exactly the same.
And that's the proof. The total mass you started with is the exact same as the total mass you ended with. The atoms didn't disappear, they just shuffled around and made new partners. The law is unbreakable.
So there you have it. We've gone deep on solids, liquids, and gases, the stuff that makes up pretty much everything we see and touch on Earth. But let me leave you with one last crazy thought. All that stuff we just talked about, it makes up less than 1% of all the matter in the universe. So what about the other 99%? The stuff that makes up the stars? Well, that's a whole other story.